Hello, good evening everyone and welcome back to this channel. In the last class we talked about the historical development of atomic model, where we stopped at the planetary model of an atom, which was proposed by Ernest Rutherford in the year 1909. Now, in this video we'll continue on the historical development of atomic models as well as the concept of atomic theory. Just like we used to say, your support is really needed in this community that we are trying to build. Please don't forget to like, to share, and to comment if you have any question or you have any comments that you want to give us on this channel, either on how to improve our channel or any other thing like that. Thank you so much, and um we really appreciate you. Now let us get into today's class. But before then, let us do a little bit of revision on what we have done before. We said the atomic model was first stated by the first atomic structure or discovery of atomic structure was first stated by two Greek philosophers, which is Leucippus and Democritus. And they call this indivisible particle, they call it what? They call it atomos. Then after 100 of years, we have John Dalton, an English chemist or an English philosopher, which stated that atom really exists and they are the smallest indivisible particle of an element, which cannot undergo subdivision. And he says that the atom of the same elements look alike in every manner, and they are different from atom of other elements. And atom of a particular element cannot be converted to atom of any other element. And I said after then, scientists are trying to work on this particular statement. Then we're having the likes of Sir Thomson that performed the cathode ray experiment and discovered electron, and also discovered the charge per mass of an electron. Where we have the experiment 1 to demonstrate the cathode ray have negative charge, experiment 2 to investigate if these rays can be deflected by electric and magnetic field, and experiment 3 where you measure the charge per mass of an electron of a cathode ray. Because he called this cathode ray, he called them electrons. So if I call them electrons, just know that electron is same thing as cathode ray in this case. Now, and he proposed the Plum pudding model of an atom, which we have actually talked about before. Then we have Robert Millikan, Robert Millikan that calculated the charge of an electron to be 1 - 1.6 times 10 to the power minus 19 coulombs. And we also have the mass of an electron to be 9.1 times 10 to the power minus 31 kilogram, and it can be minus 28 gram. So we have them like that. And also we now talk about Sir Ernest Rutherford. We have Ernest Rutherford, who proposed the nuclear model of an atom, also known as the planetary model of an atom, where we say he proposed that we are going to have a nucleus at the center and the electron that is revolving around it, just like the sun just like the planet revolves around the world, revolves around the sun. But is this model really correct? What is wrong with this model? What are the limitations of this model? These are the questions that we'll be answering in this particular video. Now let us get into it. Remember that I said that he discovered the what? He discovered the nucleus, right? Now what is the conclusion of Ernest Rutherford? Now, the first conclusion is that atom has a tiny dense central core, or the nucleus, which he actually discovered, which contains practically the entire mass. Now, you have to note, he said mass, not volume. There's a difference between mass and volume. It means the nucleus is heavy but small. You understand? Heavy but small. Where so the entire mass of an atom is concentrated in the nucleus, and the entire volume of an atom is occupied by the what? Is occupied by the electron. You understand? So that is what he's trying to say here. So he now said the diameter of the nucleus is about 10 to 13 centimeters as compared to that of atom, which is 10 to 8 centimeters. Now let's say if the nucleus were the size of a football, the entire atom will be the diameter of about 5 miles. That is what he's trying to say. I get me now. Now, the second conclusion is that the entire positive charge of an atom is located in the nucleus. I've already said that nucleus are positively charged particles, while the electron distributed in a vacant space just like I mentioned now, that the electron actually occupies the whole volume of an atom. So the whole volume of an atom is consisted of a what? Of an electron. So even if you have a football pitch, for example, now you have a football pitch, you see the football that we have on the pitch is the nucleus, you understand? The whole pitch that is surrounded by players, the players are the what? The players are the electron. That is what? That is trying to catch the football. You understand? That is just a simple illustration of that. So now the third thing is that electron were moving in orbits or a closed circular path around the nucleus, like the planet does around the sun, and they call it planetary model of an atom. So it is Sir J.J. Ernest Rutherford in 1909. He proposed the planetary model of an atom, and this is how it looks like. I'm sure that you have seen something like this before. So this is the nucleus, and these are the electrons that are revolving around the nucleus, just like the planet does around the sun. You understand? And this is a schematic diagram of it well. So can you see inside it we have nucleus and we have electrons that are what that are revolving around it. Now the nucleus is now consisting of two subatomic particles, which is the what? Which is the neutron and the proton. The proton which is positively charged and the neutron which has no charge. You understand? Because neutron has no charge, we can say that the charge of the nucleus is what? Is positively charged, and the charge of electron is what? Is negatively charged. You understand? Who now determine the charge of proton itself? Because what Ernest Rutherford discovered is the nucleus, and he knows that the nucleus consists of proton and neutron. But who discovered the charge on a proton itself? Then we can now talk about the likes of Eugen Gusten now. Now, this is Eugen Gusten, the man that actually he said that the electrical charge of a proton is equal in magnitude but opposite the charge of the electron, and the charge of the electron is negative, which means the opposite to be what? The opposite will be positive, which means protons are what? Protons are positive. So what is a proton? Proton is defined as a subatomic particles which has a mass of 1 atomic unit and a charge of +1 elementary charge units. So a proton is a subatomic particle with a 1 unit of positive charge. You understand? And it was discovered by what? By Eugen Gusten. Now, so in his practical, he also discovered a positive rays, like that positive ray is a proton. So what are the properties of the for these positive rays? First thing is that they travel in a straight line in a direction opposite to that of cathode. You understand? So if the cathode move towards the north pole, the positive ray will move towards the what? Towards the south pole. If the cathode ray move towards the negative positive pole positive plate, the positive rays move towards the what? Towards the negative plate, you understand? And they are deflected by electric as well as magnetic field, indicating that they are positively charged. So the charge to mass ratio of positive particle varies in nature of gas that is placed in the discharge tube, and they possess many times the mass of an electron. I get me now. So they are larger than the electron and they are heavier than the electron, which means the electron is not heavy at all. That is why, because the proton is present in the nucleus, that is why the mass of the atom is concentrated at the center of the nucleus. That is the reason why. So this is his own setup, and this is how he discovered the proton itself. So we don't really need to go deep into this. What you just have to know is that Eugen Gusten actually discovered what? Discovered proton. Now, moving on to James Chadwick, the man who discovered neutron. Now, he discovered that there are some particles that actually have no charge. They are not deflected by electric, they are not deflected by magnetic field. And he called this particle because they have no charge. He called them what? He called them neutral particle. Then he gave them the name neutron. That is that is James Chadwick. So in 1932, Sir James Chadwick discovered these third subatomic particles by directing a stream of alpha particles at a beryllium target. So he found out that a new particle was ejected and it is almost the same mass to that of proton, but it has no charge. It has no charge. So because of no charge or neutral charge, then he named this thing what? He named it neutron. You understand? And there is actually a chemical formula for this particular experiment, but we don't really want to go deep into that. What we just want to do is let us introduce ourselves to what an atom is itself. So then moving to into Moseley. Moseley is now the one that says that okay, inside the um inside the nucleus of an atom, we are going to have numbers of proton. You understand? There are numbers of proton inside the nucleus of an atom. Then he called this number of proton atomic number. So what are atomic numbers? Atomic number is the number of proton in an atom of an element. So you might be asked, what are atomic numbers? Number of proton in the atom of an element. And what is a mass number? Mass number is now the number of proton and neutron in the atom of an element, in the nucleus of an atom. You understand? So inside the nucleus of an atom, we have proton and neutron. You understand? What is the total number of proton and what's the total number of neutron that we have? Add them together and you're going to get the mass number. But the atomic number itself was discovered by what? Was discovered by Henry Moseley. That is the person that discovered atomic number. And I said atomic number of an element is equal to the number of proton in the nucleus of an atom. So what we have talked about so far, we have talked about Democritus and Leucippus that describe atoms, right, in the year 400 BC. So this is atomic timeline. We have 1803, that is John Dalton, that describe atom as a solid sphere, and we have 1897, which is Thomson, that discovered and that describe an atom as plum pudding. We have Ernest Rutherford that describe an atom as a nuclear atom or a planetary model of an atom. So in the next video, we'll be talking about Niels Bohr, because Niels Bohr atomic model is a very wide atomic model, and that is what they use in classical mechanics, basically classical mechanics. And we'll be talking about Schrödinger as well. That is Schrödinger wave equation and all like that. You understand? They call it electron cloud model. You understand? Electron cloud model. So they believe that electrons are in clouds and they are surrounding the nucleus, and the cloud is less dense. That is what Schrödinger believes, and that is what we'll be dealing with in our next video. So don't forget to like, to share, and to comment. Thank you all so much. Really appreciate it.